Mathematics is a subject that has paired with humanity ever since humans stood out by their intelligence and collaboration, and it has helped us analyze our surroundings. Whether it was to record food storage, population, or to study nature, mathematical modeling became an essential tool for human evolution. To promote these same principles was the purpose of Principles of Mathematical Modeling's key activity, in which I developed fundamental collaborative skills to simulate a real-life situation graphically, and whose results I'll analyze in this video. Regarding team cooperation, we managed to work together at the distance of online classes through the following methods. Zoom and WhatsApp were essential as they became our collaboration and communication channels. But at the work itself, we firstly analyzed what we were supposed to do on each stage of the project in order to decide together how we would approach it, dividing it into major steps and debating, for example, which sport should we analyze. Afterwards, we divided our duties and started to work on our Google Drive shared documents in order for all of us to be really immersed on the job. What I would promote next time, though, would be communication. I would propose to, once our individual work is done, make a final team meeting on Zoom in order to attend any doubts and conclude if the work is ready to be uploaded. Now, about the project itself, we analyzed the trajectory of a motorcycle stunt in the X Games and concluded that it deeply resembles a parabola. To reach this conclusion, we first placed a Cartesian plane on top of the image, locating its x-axis along the points where the motorcyclist almost touched the heel. Then we plotted the vertex, the x and y intercepts, along with some other points the motorcyclist followed on the plane. Afterwards, we graphed the parabola that crossed all of those points with the help of Excel and got a quadratic equation with a negative leading coefficient that was almost exactly the path the motorcyclist followed in his stunt. Now, after analyzing these elements, I concluded that there are two variables present on each location of the man. The independent variable is its location along the x-axis, the distance he traveled horizontally. This is the independent variable since it's not affected by anything as it travels naturally. Meanwhile, the dependent variable is the man's position along the y-axis, the distance he traveled up and away from the ground. This is the dependent variable as it's altered either up or down as the independent one travels horizontally. The relationship is one that deeply relates a parabola opening downwards, in which the independent variable makes the dependent increase until it reaches a maximum point after which it decreases. Thinking about it, this negative trajectory is natural. As the bike lifts off, it elevates until a certain point in which gravity makes it then fall to the ground. Well, and what if we didn't have Excel at our disposal to make the equation? Well, it wouldn't have been really that much of a problem to do so with our acquired knowledge. First of all, I would also locate some points on the graph, mainly the vertex, and a random point would be okay to figure out the equation. Then I would use the vertex form to write the equation. This form states that y is equal to a times x minus h squared plus k, in which h and k are the x and y coordinates of the vertex. After substituting my vertex on the form, I substitute the x and y coordinate of a random point of the graph in order to get the coefficient a. Once I have that result of a, I will substitute it along with the vertex on my original vertex form, and I would have now deciphered the quadratic equation. Then I could also expand the squared binomial and add like terms in order to write it in standard form. As a conclusion, this project not only helped me to understand way more better the topic we have seen through an exciting situation, but also made me realize that collaboration is key for success and that mathematics are everywhere.